Hello everyone, and today is lesson 11 of Full Stack Bootcamp. Today we'll cover persistence, an important topic for how do we keep the state of our application after closing it. How do we persist state? So we will talk about creating, updating, deleting, and reading data. And we will be using Entity Framework Core for that purpose. So without further ado, let's get to it. First, the focus of today will be Entity Framework, and Entity Framework is an ORM, Object Relational Mapper. It's what helps us to communicate with a database, a place where data is stored, and get whatever data we want. Get or put inside it. Basically, anything we do with data, we can do in Entity Framework. So you can see here is the logo. And in order for you to use Entity Framework, you will need to install a NuGet package. You can install Entity Framework by right-clicking on your project and selecting Manage NuGet Packages. And then if you type Entity Framework here and select Entity Framework Core and hit Install button, don't select this one, select the Core one and hit Install button. Since I already have it installed, it shows Update. And it will add code for using Entity Framework code. NuGet Package Manager is literally as it sounds, is a manager of packages, or rather blocks of code that we can compose in our applications. In modern software development, we compose existing code more often than building our own. So it could be compared to as playing Legos. And NuGet Package Manager is like a manager for those Lego pieces. It allows us putting different Lego pieces together into our own solution, and we make nice projects like that easily without the need of writing every single piece like these Lego pieces ourselves. So there are two options how you can install NuGet packages. One is here through using graphic user interface. And another one is by using Package Manager console. If you go to Tools, NuGet Package Manager console, you can then do .NET add package and select Entity Framework Core. I already have it, so nothing happens. But if you're new, you should be able to get it. Cool. So now that we have Entity Framework Core, we can start making changes in our code base. And the purpose of today is to make our shopping lists. So shopping list is, if we go back to our project, is basically a place where you bought something plus items that you bought. So we have a shopping list, and a shopping list has many items. And we need to persist the two. Let's go. So when we create persistence using Entity Framework, we will need a class that inherits DbContext. And this class itself will also be a kind of context. It's usually suffixed with a context word. So we have a shopping context, and this suggests that anything that's related to shopping will be persistable. And specifically, we persist either shopping lists or items, or both if we have items inside shopping lists. So there is that. And basically, the minimum, most simple way of initializing a context is by supplying some database provider for it. And if I supply a DB provider like this to an empty constructor, that means that when I create shopping context without arguments, by default, it's going to use SQLite database. SQLite database is a database that is local. So this is just at the root bin folder of my application that's going to be placed next to DLL of this application. DbContext Options Builder is something that builds options for a DB context. And the result of it, of course, is that we have DbContext options. So my builder simply says use SQLite, and then we simply get options from this builder. And that's the result. SQLite doesn't come with Entity Framework by default. Just like Entity Framework core package had to be added through NuGet, so will SQLite. It will have to be added through NuGet. So I'll once again paste the two names of packages that you should install. So same process, you hit the install button and it installs. And now you're ready to use a provider like this one. A provider is very similar to an extension method. It is an extension method after all. It's an extension method on top of the builder class that allows us to supply different providers for a DB context. Cool, we have that. Let's continue. So data in DB context, instead of a list, must be within a DB set. If we say that data is within a DB set, then that simply means that that data is within a database. It's persisted. And that's the key difference between just a simple list or any other collection. DB set makes it persist. And if we want to hook this shopping context with the rest of application, all we have to do is to call a special entity framework method called add_DbContext and specify our DB context. And now, whenever we inject this DB context, it will be accessible for us. Please note that we did not inject this context using methods like addSingleton, transient, or scoped. We used a special add_DbContext method, and it does a little bit more under the hood. We won't go into that much detail. Just try to remember that it is the way to go. That's the way to go. Let's go. Now we have a service which did a bunch of business logic, but now we need another component which could simplify interactions with a database. In other words, we need a class that handles database interactions. A class that handles database interactions is called a repository. And a repository is usually made per a single entity that can exist by itself, an aggregate, in other words. So I will create a shopping list repository which has a DbContext and I'll do a resharper keybind ctor f to inject the shopping context. And now I need methods for my shopping list. So what can we do with shopping list? We can get shopping list by name. We can create a shopping list. So I'll just paste those methods if it stops lagging. Hopefully it unfreezes. I'll save and open it again. Cool. So we have two create methods. Okay. We won't need get random item. We will need to get all shopping lists. That's fine. We will need to get shopping list by ID. We will need to add an item, but that's for a different repository. We will need to update shopping list. We will need to delete and update shopping list name. Okay. And delete. So we have a so-called CRUD, create, read, update, delete kind of methods. I have no idea why was it duplicated 5 times, but okay. Again, it's buggy. I don't know why is it so buggy. I don't know why did I close Visual Studio as well. Cool. So let's take those methods. And as I mentioned, for every entity that can exist by itself, we create a repository. So I will create actually a separate folder called repositories. And here goes the first one. Okay, really slow for some reason, but we moved the first one. And let's create another class called items repository. I will paste the methods that we need implementing. This method for item and other methods for shopping list repository. So I'm pasting constructor because it's going to be exactly the same, except with different methods. So this is just void. And I will create a bunch of methods. Get by name, we're getting a shopping list. Create text, get a bunch of shopping lists. We get a shopping list. Update shopping list, we get a shopping list. No, we don't get anything, we don't get anything, we don't get anything. Cool. And open scope for each. Cool. So we created a bunch of methods that we will soon implement. Oh, what the hell? Still a bunch of deletes left. No problem. For now, I'll just placeholder them with nulls. Whatever needs returned, I'll just null them. So that we have a nice skeleton that we can later on fill with logic, proper logic. Let's fix the namespaces names. And let's start with implementation. So how do you get data from a DbContext? It's very simple. So I specify the context, the DB set that I want to access. In this case, I'm looking for a specific shopping list that can be that can be found by name. Like this. So here you can see the most simple get method. Let's try and use this repository. Repositories will be used by services. So let's go to a service and inject the repository that we want. And let's generate a constructor that injects that repository. And now for a method that gets a shopping list by name, never used, huh? Really never used. I saw it used in the controller. Get by name. What is going on with my Visual Studio? I have no idea. It's bugging out. I'll restart once again. Okay, so I will undo. Oh, I cannot undo. There are Git changes that I want to. So this service had this method that I deleted. I'll bring it back. So we have this method that will now call this service, this repository, I mean. Why is it lagging so much? It literally never does. Cool. And that's our method. But now there's a little problem that I actually hid from you up till now. In my database, I have replicated item and shopping list models. Actually, I did so for a very simple reason. Let's compare the two items. And you will notice a significant difference. Oh, come on. First item and second item. I said item right here. You see, the item on the left is really plain, simple, and stupid. The item on the right, however, has a little bit more depth. Specifically, we actually capitalize the first letter when we return it. So even though they share the same shape, they don't really have exact behavior. If we look at a slightly more complex example for a shopping list, you will notice the same pattern. That the thing on the right is way more complex than the thing on the left, and this time it's way more visible. For example, we have this calculate total cost method. We have add and update methods. We have these IEnumerable and total price properties, none of which exists on the model on the left. It's a big and important distinction between these two things. And actually, if we look at a different kind of shopping list, we even have tax shopping list right here, which is yet another complexity. So basically, in my shopping list class that I'm going to put in a database, I need to flatten out, like simplify the structure as much as I can. It doesn't have to be flat. I can still have relationships with entities, like an item to a shopping list in a one-to-many relationship, but I do need to get rid of all other logic. If I can simplify it, I should simplify it. That's the key principle in database. My tax policies are progressive and fixed. Progressive tax policy is literally always the same. It's either there or not. Let me show you. So there is no variables. There is a fixed range of prices which invoke a specific task. So if I am at, so basically I need to say that is progressive. I need to specify that to my shopping list. Is progressive taxes. And I also need to specify this. Decimal. I need to say, is it fixed taxes, because we have progressive and fixed taxes. And this is what we will need. And that's it. That's the model that we will save in the database. Let's go back to a repository. And let's try to fiddle with this method. We aren't supposed to be returning this model. We're supposed to be returning a model from models folder, because whatever we have in a database folder right here is needed just for a database and nothing else. It shouldn't leak to the outside of our program. It should only be used for database stuff. So we will have two using statements, which I alias with db and domain. Like this. So this one is actually db. And everything here is actually domain. And internally, everywhere, I will be working with database stuff. But externally, input and output will be from my domain stuff. So we get shopping lists. And now I basically need to map these shopping lists into domain shopping lists. Like so. This is where we'll store them. And for each shopping list, we will do the mapping. Cool. And the shopping list, we will set stuff. Sorry, I made a mistake. It's not so simple. So this is a domain shopping list. And I don't know which shopping list I will be creating, but it all depends whether there are tax policies or not. So I first need to determine whether it will be a taxed shopping list. How do I determine that? If my shopping list it's not first or default. Oh yeah, it is. Sorry, it's not a for each. I made a mistake. Like this. List. It's a single shopping list, so I don't need this list as well. Okay, cool. So if my shopping list has either this or fixed taxes not null, then it means it's taxed. And if it's taxed, the shopping list I create is going to be taxed. And with these policies, so list. So progressive. And another one is going to be so I add this to policies. And I'll add this to policies as well. And I'll pass in the value of this fixed tax for this policy. Cool. And then my shopping list, well, I will also add it. So here, like this. And I will feed the policies in here. Hello, F. Cali. And we have this one. And if it's not taxed, then we simply create a normal shopping list. And that's the basic mapping. Sorry, that's the advanced mapping, and now the basic mapping is left. So we need to feed it the shop name. So it comes from this shopping list shop name. We need to feed it items, and everything is very easy now. It just maps directly. Kind of directly. Address, shopping list, address, ID, ID. Total price, we don't care about that. That's it. The last bit is mapping this. Let's have a mappers folder to make easier work of conversions, because this will get out of hand if I don't manage it. So I can move this to mapping, like so. Shopping list mappings, and another one will be item mappings. So in shopping list mappings, we'll move this one. Public, static, for now void. I'll rename soon properly. Let me get the using statements that we used in here, because they're definitely useful. And yeah, so we map from database shopping list to domain shopping list. It needs to be static as well. And the same goes here. We pass in database item, and we get back domain item. And this one is easy. Like this. And now I can use this in my select of link queue. Almost. Yeah, it has DB items. So it should work. I forgot a this keyword, right? And I forgot a static class. Okay. Cool. Has no setter. That's fine. We can convert this to list. And map. Cool. And do a for each, which goes to our domain shopping list. And adds the new item, the domain item. That's mapping of shopping list from one shopping list to another, and that's mapping from one item to another. Of course, we will also need the opposite. Will we? Yes, we will. So let me add that too. And of course, this will return this one, and this one will return this one. Cool. And I'm missing a return statement. And here I'm missing this statement. Okay. Yeah. So this time is a tax. It's going to be determined by this class, because I will be in control of this when I'm adding it, I think. And these can go away. These can all go away. I will be returning this. I can immediately also create the shopping list. Cool. And now let's see what I can do. So first, basic mappings. Address. ID. List. Select. Okay. And fixed taxes. So the last bit that I don't know how to solve, actually. Well, you see, this domain class, it has policies that are not this one, sorry. This one. It has policies that are private. I'll make this public, but purely because I am unable to come up with something smarter as of the moment of speaking. I'm pressing double Control R and making this a get only property. It's not nice what I'm going to do, but it's quite complex, to be fair. but it's realistic that could happen. So we have fixed taxes. I'll do it once again, slightly different. Like this. Okay, and we say this. First or default. My link view is broken. Why is my Visual Studio broken today? So if P, oh, right, I know. Get type. Progressive tax. What's it called? This one. Wow. I'm turning off ReSharper. It might be messing up my Visual Studio. It's not working. That ReSharper really. Cool. So type of progressive tax policy. Yeah, include, come on. Sorry. Back domain, this one. Yeah, cool. Cool. So if, yeah, so first get policy, progressive. Well, or rather is progressive is what I want to find out. If this isn't equal null, it's progressive. And then let's get another policy. Is fixed, or rather decimal fixed tax. So we're getting a policy of type text. As that policy. And we will mess it up a bit once again. I hate this code actually, but I'm tired enough to not be able to figure out anything better. Fixed. This one. Let's make this public. Yeah. Cool. Let's go back. Yeah. Cool. And taxes. Like this. Cool. And now we can add the remaining bits. Like so. Not an easy bit, and definitely it's enterprise worthy. I did not intend to make this so complex, but it happened. Okay. Cool. So we have. Why are you complaining? Oh, here. Yeah, it doesn't contain that. So I need to create one last method for mapping. This one for the opposite. That takes this and returns this. So I'm creating a DB item and that maps with the other item, which is as simple as that basically. Cool, very simple, nice. And the method exists, and I just need semicolon. Okay. And I have the mappers. So now I can go back to my repository and finish the implementation. So I'm returning stuff from context that is mapped. Like so. Domain shopping list. Perfect. So that's the first one. And you'll soon notice a pattern. You see, when I return something, I call map in the end. When I persist something, I call map at the start. And after I do any changes in database, in order to confirm those changes, I need to call save changes. That's just how DbContext works. And this is actually irrelevant. I can simply use this because my method supports both ways. Now I first get stuff, all shopping lists db from the context. I call to list because otherwise I get iCurable. iCurable is database stuff, it's entity framework stuff. iCurable is a query that is meant for running a SQL expression. But when I call to list, I execute that query. So at this point, I'm working in memory with C# and not SQL code. So I need to return this. So once again, I can return this in one go. So I select. And that's it. What about here? Here I do a get. So for search by ID, you can simply do this. And the key difference from where and find is that this will first look if that shopping list by that ID was already retrieved. And if so, it won't go into a database, but rather retrieve it from Entity Framework's cache. Okay. Update shopping list. So okay. For this one, if I remember correctly, we already have an updated shopping list. So all we need here is, I'm not sure. We'll leave this for later. Shopping list name, the same here, and delete is similar as any other adds and other methods. So we simply find. Sorry, we can do it in two ways. So first one, we can create a shopping list for DB. With this ID. And simply call context to remove this shopping list. And of course, call changes, save changes in the end. And that will be enough. Get by name. Yeah. So let's integrate that repository in here. Get by name. Shopping list API models shopping list. And this one is, oh, I see. It's supposed to be many, so it's a where, and this is iNumber, because there might be multiple shopping lists of the same name. So I need a select statement. Like this. Cool, done. I think it can be simplified. No, it cannot. Cool, done. I will provide those just so that it doesn't get angry at me. And if I run my method now, I will not get anything at all because I still need to have a way of creating those shopping lists. Hello, Kelly. Oh, yeah. Hello, Magisterium. Yeah. Cool. So let's go back to service. Service. This one. And let's implement the remaining methods. So no more we'll be using this dictionary because we now have a database, so no point of using in-memory stuff. So for total cost, we will get all shopping lists. Like this, and it remains the same. For add, we'll create a repository create. For get, we will call repository get. For this one, we will call repository get by ID. For this one, we don't need this anymore, and we'll call repository delete by ID. For this one, update shopping list name. Cool. We'll call repository update shopping list name. We can actually do it in 2 ways this time. But I think this is fine. Okay, weird method. I think this was supposed to be a string. Yeah. So we implement this by saying from shopping lists context, give me a shopping list by this ID. And set the name of that shopping list to this one and simply save changes. Cool. Let's go back. Return. Now I need to update shopping list itself. And add item. For that, I will need another repository. Items repository, and I will rename this repository to shopping list repository. And this will be underscore items repository. Let's add to constructor. And let's change this one a bit. Cool. We are done. So let's just add some placeholder values here. And let's finish this method. So for this one, we call items repository, add item, and we pass in this item. And obviously the shopping list ID. And I will add these two as well in here, because we always need to think about mapping. So we pass in always domain stuff or return domain stuff, and internally we map that the database item. So we call context, items, and we add our DB item. And of course, like always, we call save changes. And this is DB shopping context, and this is DB shopping context as well. Cool. And sorry, I was supposed to add this to a specific shopping list. So I need to link this item to a shopping list. That's more like it. So we have a bunch of super simple near one-liner methods in our service, and it's time to test it. So let's get the service running and see what happens. It says some services are not able to be constructed. And of course, because I am yet to inject my dependencies, these two guys. First off, let's create an interface for each. I'll simply copy paste this interface because I know for a fact that they are going to share the same interfaces. So copy this twice. I know that this one cares about all except that, and this one cares about all except that. And this is my shopping list repository interface, and the other one is items repository interface. Whoops. Like so. And this item is domain item. Always the input is domain stuff. And same here, it's all domain stuff that's in the interface. We don't want to leak our database models because that causes a ripple effect and will make it harder to maintain. And implement this interface. What's wrong? I don't know what's wrong. It doesn't implement calculate total cost. Of course it doesn't. It shouldn't. Next. It doesn't implement add shopping list. Does it not? It's called create, isn't it? Yeah. So let's rename it to add. Next, it says find shopping list. We have a different name for that. We have get. We have delete. Whoops. We have update name, and we have simply update. Actually, this can be update too, because you can deduct what we are updating from parameters. No more errors, hooray. And for item repository, let's rename this to create. And this implements item repository. Awesome. And now I need to inject those. Oh, first I need to change to make sure that my services, that they depend on abstractions. Repository. Good. And what's wrong? Get by name. It's a get. No. Okay. Oh, I'm missing this get by name. Okay. Cool. Done. Awesome. No more error. Perfection. And in my startup, I just now need to add those services. So we can now make this transient because there is no need to statically persist those lists of items. We have a database after all. Right. Cool. That's the first one. And that's the second one. And now it should work. It does. So if I open Postman and test my database, let's see what happens. What happens if I create a shopping list? Error, no database provider has been configured for DbContext. Let's go back. Is that really true? If we go here and we see this, it shouldn't be true. Let's go back to the error itself. It says no database provider has been configured for this context. The provider can be configured by overriding the DbContext on configuring method or by using add DbContext on the application service provider. If add DbContext is used, then also ensure that your DbContext type accepts DbContext objects tContext. It kind of does. Like this. Let's see if it changed anything. It certainly did not. And passes in base constructor of DbContext. I do that. Yep, I do pass the options to the base constructor. What is going on? Let's comment this one out. Sometimes it gets messy when you have multiple constructors, but I highly doubt that it solves any problems. It did. It surely did. Cool. So now we got to actual problems, and the problem says there is no such table, shopping lists. Shopping list table doesn't exist. Well, our database is in here. Come on. It should be in here. Shopping list API. It's called shopping list DB. It's not even here actually. Okay. So we need to create a database basically. So let me open command line, and we will be needing to perform a few commands. I don't remember those commands by heart ever, but I have them marked. So right. Basically, you need to run this command. Let's call first. We won't specify the context, we don't care. And run. No project was found. Where am I? Let's try to run this in here. No project was found. What the crap? It should have a project, definitely. Oh, maybe because it... What is it called? Oh, okay. It's fine. Shopping context. Yeah, what's wrong? Oh, right. I removed this, so it no longer computes. Let's comment this out. Cool. Awesome. Let's run again. Yeah, no table. That is fine. Oh, here it is. So the table is literally at the root of my project and not in a bin. Cool. Let's see. Let's open it with SQLite Explorer. Yeah, 0 tables. There's a table, but it has 0 stuff in it. No project was found. What do you mean no project was found? It literally doesn't make any sense. I'm literally at the project, so. But whatever. Build failed. Because it's being used by another process. Great. Let's kill everything. 2 errors. Okay. Let's do it again. Okay. It's still running, so I need to stop these sites, I think. And it should snap out of it. Yeah. Build succeeded. Okay, so now it says your startup project doesn't reference Microsoft Design. So often frameworks like Entity Framework will give you hints of what went wrong, and following those hints, you can set it up properly. So this package is needed so that I can generate a database out of code. So let's install it. And let's try again afterwards. I'm a bit surprised why is it doing everything so slow today, but okay. Great, and now it should work. Yes, it does reference it. No, it doesn't. So I am a bit confused now. Did I install this to the right project? Build succeeded. Let's try again. Oh, okay. I had to build it. So if you look closely at what happened after I ran this command, I'll paste in the chat. Chat. Okay. It generated a folder called migrations. And this folder is basically a bunch of SQLite, well, that's the provider I use, tables. So this basically generated SQLite table definitions. And to continue, I need to actually apply this migration and not to just generate it. So this follows up next. And I'm mildly ignore that I need to specify project every time, because usually that's not the case. It's okay though. So we applied our migration to this database. And so if I refresh it now, I don't know how to refresh it. Let's reopen it then. You should, oh, come on. You here, yeah. You can now see our tables. So that's really cool. And you also see migration history, an extra table that's added by Entity Framework, so that you can have multiple migrations and a way of going up and down. But we won't talk about this that much in this lesson. So if I start the application now and run Postman, it succeeds. And let's see the multiple things that we can do with it. For example, add item to shopping list. Add a few items. And create a tax shopping list. Yes. And let's add some items to shopping list too. And let's get all shopping lists. Something is wrong with, yeah, getting items is a bit messy. So we'll need to figure out what went wrong there. But everything else seems to be working. So let's stop it. And let's go back and see what we could have messed up with our item repository. Right. I think we had to do it the other way around slightly. I think we had to get well, getting a shopping list by shopping list ID would certainly work, but it's a bit of an overkill. Like this DB item. So this should work. I'm pretty confident, but that's not the right way to do it. That's not really the right way to do it. Why did I close Postman? So the key point now is that, I restarted my application, but my shopping lists are there. That's a major difference compared to the previous version where every time I had to create new shopping lists. So let's add a few shopping list items to shopping list 2. 1, 2, 3. And see what happens if I get shopping lists now. Nothing. I would like to debug because I genuinely don't understand what went wrong. So we map this item. It has ID 0, so nothing really. It has no shopping list, and we don't care actually. We find the shopping list, we add an item to a shopping list. And we save changes. So what went wrong? Okay. Get all shopping lists. Let's see what happens when we get shopping lists. Yes, this one. I don't care. Wait a minute. Oh, okay. 0, 0. Huh. Why? We map the item, we find shopping list, we add item to shopping list, we save context. In that context, there is one item. Let's see the database. How many items do we have? We have many items. 2 different tables. So where did we make a mistake? Where did we mess up the connection between a shopping list and an item? That's a really nice exercise for spotting a mistake. I think it lies in a shopping list. The problem lies in shopping list. Here. Usually it's iCollection. Yeah. Is this messing it up? It could. Let me check my notes. Let's try it like this. Get all shopping lists. Nothing. Okay. Let's try it like this. So I thought it's equivalent, but in my notes I put it like this. Not here. Here. I don't think it will change anything. Yeah, it didn't. Well, usually these properties are virtual, but again, I don't think anything will change because it has something to do with lazy loading. So it shouldn't matter, but it's worth a try. Shopping list ID. It's not misspelled. Yes. Let's inspect database if there's anything wrong. IDs make sense. Everything makes sense here. IDs are correct. Let's see. Foreign key. Shopping list ID. References. Shopping lists by ID. Everything seems to be correct. I'm puzzled. I'm puzzled. Need. Okay. When in doubt, there is one more thing we can do. We can debug by setting up entity framework so that it logs. to console or similar. Let's see. There is this option. So we can do this. Like so. And now it should log SQL that it tries to execute to debug window. Let's see what happens now. Oh, come on. Send. Continue. It's so annoying that I don't see the output window. Here we go. So what does it say? Select. It doesn't try to do any join at all. Oh, I forgot. I'm sorry. I forgot. I went into my own trap, actually. I will definitely mark this to be added to the lesson section. So by default, when you query entity framework, you will just get the main entity that you are trying to get. In our case, we're getting shopping lists. So we are only getting shopping lists. And if you want to get something more, you have to ask for it. So you need to call include. And oops. Come on. It has to exist. So I want to include all items as well. And then I convert that to list. And this should solve the problem. So let me change stuff where it made no sense. I'm not sure what to do with the find, but we'll see. Well, we'll see about this one. This one's fine, this one's fine. Okay, now it should have fixed that error that we had. So if I get my shopping lists, hurrah, it includes the items and proper prices. Cool. So if I get a specific shopping list, it doesn't include items. How do I include items when I get an entity by ID? I don't remember, legit. Is there really? EF4 find and include. So I cannot use find. Okay, that sucks. That really does suck. Unfortunate, but so be it. So if we call this now, we get our items back. Awesome. So that is fixed. And I think, let's see if it really works. All the mall for shopping list 1. So we get 1, it should be all the mall. It didn't change, so of course, because we didn't do this yet. But we have an update name method, so there's another one. This one. So do it and get that shopping list by that name. Yeah, it changed, and testing like this, and let's implement this. And the last thing that we're going to do is to do a full update. So we find the shopping list by that ID, and we basically map this so that we have a proper update. And the last thing for us to do is literally shift stuff of this into that. So the ID doesn't change, obviously. This one, it changes. I will not change items. I don't care about items. We have an add method after all. Well, this one won't change either, actually. So we'll change address. I think last time we changed that. So I don't even need to map that. So we'll just change this and address. Then we call context state changes. So that's all. So let's say address like this, and we hit save, and we get that shopping list by ID1. We can see that it didn't change the address because address was non-capital. I'm not sure actually why it didn't change. Oh, I used it in the wrong place, sorry. It should have been here. So if we call this, you can see shop name is now null, right? Because I didn't provide a shop name. like so. So here you have it, like a fully fledged API that does what you want and actually is really, really enterprisey. This is very impenetrable. The requirements can change, database can change, models can change, and you will have a minimal impact when you actually need to adapt to that change because you separated database and domain. Database is not a business problem. Database is an infrastructure problem, so it shouldn't impact your design choices. And now we're free from that, and we have persistence. High quality persistence, in fact. How do you test database stuff? That's the last topic I would like to cover. So we have this DbTests class that we need to fix, actually. We do have to write test cases, that's right. But I just wanted to show an example. And I was wondering, why do I have this and then I have this? Let's see. I don't understand, but let's see. It was erroring last time. Yeah, no database provider has been configured. I remember that it used to work like this, but now it doesn't. Let me have a look at my notes. I think it's the way I inject the thing. That's the only logical conclusion I can come up with. Let's see. Let's Google it. Well, this guy doesn't have a DbContext options. So many bad fixes. That's unfortunate. That's not correct. That's really not correct. So basically, I'm trying to support multiple providers, but right now I only support one. So if I run this, it will complain. Yeah. So what if I change the order of constructors? I'm not sure if it matters. Yeah. So it tries to call this constructor and obviously fails. So my problem is multiple constructors. Uh, that's false. Okay, you're done. That's not true. Let's see another one. Well, we could do this the other way too. Yeah, that's right. Can do it like this. So what is this? Builder. So I want to use SQLite. So I want to move this basically to another place. Like this. Cool, awesome. Uh, like this. I don't need the debug statement anymore. I don't need this anymore. I just need this. Perfect. Let's run and let's revel in the results. So now it works. And the last bit I wanted to show is that here we have our database. And we can actually set the context to use a different provider for testing. And the provider we will be using for testing is in-memory database. So let's update our tests. I'll show you how the gist of database testing works. So in a constructor, you set the database up and make sure you implement iDisposable so that here you dispose of the database that you connected to, like so. And in, let's say, this service, no, not service. Service is boring. Yeah, service is fine actually. We'll do something like this. We'll inherit database tests because it is database tests. And we'll need to create repositories. So tests, private, read-only, shopping list repository. Come on. Shopping list repository. Private, read-only, items repository. And we create them by feeding them the context. Like so. Cool. And if I pass these guys in here and run my tests, I expect, go to implementation. Come on. This is abstract. I expect the test to pass. So let's open the test explorer. Let's expand to where it says shopping list service tests. And then let's run those two tests and see what happens. They failed. It says the instance of type entity cannot be tracked because another instance of the same key valid for ID is already being tracked. I have no idea what's wrong. Well, I kind of do, but not really. And this one, expected argument exception, DB exception entity which does not exist in the store. Interesting. Wait, sorry. Misclicked. Misclicked, awful. So what can we do about it? Right. This is fine when shopping list exists. So we add a shopping list, we then remove it, and we expect it to work. Yeah, sure, it should work. One failed. At which line? At delete. Let's see what happened. There's one shopping list with ID 1, the one that I'm trying to remove. Okay. It makes sense, I think. So I'll need to change this. The problem is that we fetched an entity with that ID. And we are trying to remove an entity that was fetched already, and it simply doesn't work, unfortunately. Because it's already tracked and it's considering it double tracked, so cannot compute. Let's do it like this. And run the test, and I'm confident it will pass. So that is how you test database stuff. Nothing special, really. I didn't change anything in the test itself other than passing those two components, which are needed anyways. So that is Entity Framework basics. Well, not even basics. That's more or less like 50% or a bit more than you need that you need to know about it. It's simple, easy to get started, difficult to master. Next lesson, we'll have a look deeper at SQL and tables and database stuff itself. And after that, there will be a 1 month or so break before we continue to front-end stuff, to React, to be more precise. So I will commit this. Added persistence, basically, is what we did. So thank you, everyone, for watching, and see you next time. Bye.